Here's a little bit of help for you for Unit 4, Lesson 5 homework. Our job here is we have two different parts for this assignment. First thing we're supposed to do is complete the equation, complete the statement about how you would actually solve the problem. So we need to talk about the steps that are given. We'll start right here with item A. And the first thing that we're talking about here is it says that we're going to distribute 2 on the blank side. In this case, we do want to talk about, this is our left side over here, so we're going to talk about distribution 2 times x plus 2 times 5 for that side. And so we could say on the left side, blank -1 to each side. This is where I wanted to readdress something that I may not have done very well before. So 2 times the sum of a number and 5 is equal to 3 times the number plus 1. After the distribution, 2 times x and 2 times 5, I know 2 times 5 is 10. In the past, what I've talked a lot about is simply subtracting 1 from the right side, subtracting 1 from the left side. What I would like to revise to a little bit on this one, or to remind a little bit, is I've also talked about adding the opposite. So adding -1. Adding -1. Adding the opposite is the exact same thing as subtraction. So if we're talking about the opposite value here, we want to say +1 plus a -1 is going to be equal to 0. +10 plus a -1 is equal to 9. Those steps that we're talking about with that, I want to make sure that we understand that we can have both subtraction and adding the opposite, or in this case, adding -1. And so when we go through, oh my goodness, I keep writing this wrong. When we go through towards the end, this will be really important as we get to our next step with this one. So we want to add -1 to each side, and then blank a -2x to each side. In this case, since we have a +2x, the only way to make this work is to add a -2x, which makes this 0, and add a -2x, which makes this just 1x, is equal to 9. And what I find out from here, same thing, add the opposite, add the opposite, add the opposite. If I'm going to subtract, then I subtract the value. And then what I'll end up doing in the second part, part B, is I will need to solve part A, part B, and part C. And I know that I've already solved part A. So part A, the answer would be right down here, x equals 9. I don't want to just right away jump right into it and say, oh yeah, that's correct. Because remember, I can figure out if I'm right before I actually put in there. I just have to substitute back into the beginning. So twice the value of 9 and 5 would be twice the value of 14. So that makes this one 28. And then 3 times 9 plus 1 is 27 plus 1, which is also 28. Since I have an equal relationship right here, I see that both expressions, when x equals 9, come out to a situation where both expressions are equal to each other. So I know for a fact, part B, letter A, x equals 9. Go ahead and get after the rest of those. Don't forget to check your work. Number 2, sometimes checking your work is also called verifying your solution, making sure it's true. That's something that happened here in this one. Claire was solving an equation, but when she checked her answer, she saw that her solution was incorrect. So when she sees that her solution was incorrect, she saw that a -7 was incorrect. Here's what that looks like. 12 times 5 plus 2 times -7. This is what she did to find out she was wrong. Equals 4 times -7 minus, I'm going to come down here just a little bit, 5 times 9 times -7. And this is grouped. So let's go ahead and simplify everything. First off, 2 times -7 is -14. And 5 plus negative 14 would make this negative 9. And so we have 12 times negative 9 is equal to, over here we have negative 28. And then a minus 9 times, or a 9 times negative 7 is a negative 63. And 5 minus negative 63 is going to be 68. So negative 28 times negative 68 is going to be a positive. And without even going a step further, I know right now, or she knows right now, this answer over here would be a positive value. This would be a negative value. And since it's pretty obvious that these two answers, or these two expressions, can't be equal given the solution that she came up with. So we need to find her error. This is how she knew that her answer was wrong, is looking at the final values here. She knew that that the two expressions won't be equal to each other, that these two expressions won't be equal to each other when y is negative 7. So let's go ahead and look through this and figure out, where did she make a mistake? I see 12 times 5 right here, and I know 12 times 5 is 60. Well, there's a mistake right there. And 12 times 2y is going to be 24, so that's good. 4y minus 5. Looks like she might have done something a little bit different right here. So this little section right here, it looks like she simplified and used the distributive property, taking this little section right here, the opposite of 5 and the opposite of minus 9y would be a positive 9y. That's good right there. Let's see if she made any more mistakes as she went. Assuming that we change this to 60 as we go. Let's see here, 4y. Let me go ahead and get rid of some things. 4 times y combined with 9y. This is what we call like terms. These are called like terms because they have a y that's raised to the first power. They have the exact same variable raised to the exact same power. And that makes them something that I can combine together because they're both unknown products. But because they have the exact same variable that's unknown, we can go ahead and combine them together because we know that they are going to be multiplied together. So if I have, it's like looking like this. I have y plus y plus y plus y. This is the 4y. And then I have 9 more. You get the point. Well, if I have 4 y's and I have 9 y's, altogether I'm going to have 13 y's over here. And that's why we can call these like terms. With that in mind, 13, this one and this one is 13y minus 5. She subtracts the 72 from here, subtracts the 72 from here. So it looks like most of her steps here, I mean, she did everything pretty darn well, except right there. Needs to know the multiplication a little bit better. And then you need to solve and get the correct solution at the very end. Right here. Tell me, what is the correct solution? Question 3, a little bit of review. Tell me all of the statements about the line and its equation. Some things I would tell you to look for. I would tell you to figure out what is the slope, moving from point to point. Well, that doesn't look very good. So look at the slope from here to here. I would tell you to pay attention to the y-intercept right here, that little point. I would tell you think about how many different ordered pairs could show up on here. And I think drawing this will show you that this one right here, there are 2 solutions. That one's out. There's a lot of solutions that could go with this one. But think about all those pieces. Infinitely many solutions means there are lots and lots and lots and lots and lots, unlimited solutions that could be on this line. Think about these other pieces. There's solutions here and here and here. Anywhere on the line are solutions. So pick all the ones that are true. And then the final question. Participant in a 21-mile walkathon walks at a steady rate of 3 miles per hour. He thinks this really are the relationship between the number of miles left to walk and the number of hours I already walked can be represented by a line with a slope of -3. Select the best statement about whether you agree with this claim. I would like for you to pay attention to a couple things. This is a 21-mile walkathon. He's walking at a steady rate of 3 miles per hour. And he thinks that it can be written between or as a fraction or as a relationship between number of miles left to the number of hours walked. So we're talking about miles left compared to hours walked. We know that a ratio like this can also be written like this. Two hours walked. And he says that equals to -3. Don't forget that that can be -3/1. So consider that piece, go through, decide which one of these claims would be accurate, A, B, C, or D. And that's all you got. Thanks for tuning in. Make sure you have a great day.